Hello, my dear students. I hope you're all doing well. My name is Benathan Patton, and I welcome you all to the channel Classroom, where we learn together. So, my dear students, in today's video, we are going to learn about image formation by convex mirror. We are already done with image formation by concave mirror. So, this topic comes after image formation by concave mirror. Okay, so we will be studying about convex mirror. How many cases are there for convex mirror? Now, before you answer me that question, how many cases were there for concave mirror? Altogether, there were 6 cases, isn't it? For concave mirror, it's very less. We have only 2 cases, okay? So, remember the rules, the 4 rules, rule 1, rule 2, rule 3, rule 4, because you will be needing these 4 rules to draw these image formation cases, whether for convex mirror or concave mirror. So, these rules are very, very important. So, if you are not thorough with these rules, make sure that you you get yourself thorough with these rules first, okay? Because it is very easy once you know these rules. All right, so without wasting further time, let's jump to a lesson. So let me grab my marker, because this is very important for me, okay? This is very important for me. I write with this, and then through this I'm able to deliver my I'm able to discuss the topics through this marker. But for you, from your end, you have to do one thing, which is grab a notebook, grab a pen or a pencil, and make sure that you take down whatever we're discussing here, because this is going to serve as a useful note for you. So without wasting further time, let's jump to the lesson and let's start learning, okay? So, I'm in a rush today, the energy is overwhelming, okay? So, well, now, 2 cases are there for convex mirror. So let's break this page in the middle and let's start learning, okay? So let me break it here. We will start with the first case, which is case 1. So case 1. Now, remember, my dear students, that in every case you have to mention where the object is. Then you will have to mention the image position. Then you will have to discuss, you have to mention the size and the nature. All right. So let's start. So in case 1, object position. So let's write object position. Object position. So we are to write where the object is kept at. Now, who will tell me in which where was the object kept in concave mirror? Yes. Who will tell me? Anyone? Yes, very good. Object was kept at infinity in case 1. Remember, in all the cases, okay, in both the mirrors, concave or convex, object is in case 1, object is always kept at infinity. Okay, so object position will be at infinity. So we will write at infinity. Infinity. Now, then image position will write image position. Image position. Then after that, we'll write the size and the nature. So image position, I think I'll keep some space here. Then we'll write the size. And finally, we'll write the nature. So these are the things that we will be writing. So let's draw the ray diagram. It's a convex mirror. So convex mirror will be drawn. I'll draw here, okay? There's a space here, so let me draw here. So convex mirror, so it will be like this. Remember, my dear students, convex mirror, the image is formed on this side, okay, on the right hand side. So let's show the non-reflecting side. This is how we show the non-reflecting side. Let's mark the pole at the center of the mirror. This is the pole, mark it P. Then I'll be drawing this line. What is the name of this line? This line is called the principal axis, okay, which passes through the pole of the mirror, and focus and center of curvature, they all lie on the principal axis. All right, so we will be considering 2 rays, okay, 2 rays. Remember, whenever the object is kept in infinity, my dear students, always remember that we will be considering 2 light rays, and these 2 light rays will be traveling parallel with respect to each other, as well as parallel to the principal axis. Okay, so let's draw those 2 rays. So ray number 1, let me draw this as the ray number 1, and ray number 2, this will be the ray number 2. So this is ray number 1, this is ray number 2. The object is at infinity, so these light rays are coming from infinity. Let me just show like this, just to indicate that they are coming from very far distant sources. Okay, now Remember that we are studying convex mirror, and you have to remember the nature of the convex mirror. Concave mirror are converging. That means light rays after touching the mirror, okay, light rays after touching the mirror, they converge. Whereas convex mirror, light rays after striking the mirror, they diverge. So convex mirror has diverging nature. So what will happen to this light ray? This was traveling parallel to the principal axis. This is the point of incidence, and after striking the mirror, it will diverge. Okay, it will diverge. So it will diverge. So let the ray diverge like this. Let it diverge like this. So this is how the rays will diverge. Now what we do is we trace it back. We trace it back, and then it will follow rule number 1, which is it will appear to meet at focus. So this will be our focus. Then let's do the same thing for this second ray. So this will also diverge. This is the point of incidence, and it will diverge, and then we will trace it back. So let me just get it right from here. It will go like this, okay? And then what if we trace it back? Then they appear to meet at focus. So this is where the image will be formed, okay? At focus. So image position at focus. This is focus. Image is formed at focus. Size of the image. What will be the size of the image? The size of the image is point size. So the image is point size. Point size. Okay. This squeaking sound, which is produced by the rubbing of my this marker with a whiteboard. Okay. Some of you may find it irritating. Please don't mind. Okay. I can't help it. Okay. This squeaking sound. It's something that can't be. I can't help it. Okay. The nature. What will be the nature? Yes. What is the nature of convex mirror? Concave mirror and convex nature. Concave mirror. You are studying convex mirror. So what is the nature of convex? What will be the nature of this image? What will be the nature of this image? The nature of this image will be, see, it is formed behind the mirror. Okay, it is formed behind the mirror. So the two reflected rays, they do not actually meet. Remember, they do not actually meet, but we trace it back, and then on tracing back, they appear to meet at focus. Those images which are formed, okay, which are formed on tracing back, okay, those images which are formed on tracing back the reflected rays, they will always give you a virtual image. Okay, so these are called virtual images. Understood? So this is a virtual image, and remember, virtual images are erect. Understood? Concave mirrors will give you, out of the 6 cases, 5 cases will give you real and inverted. Go and check it out. All the images are inverted. Remember, in terms of mirror, inverted images are real images. In terms of mirror, erect images are virtual images. This is an erect image, so it is a virtual image. Okay, remember that. And then also remember that virtual images are formed by drawing the reflected rays backwards. The same thing is happening for case 6 for concave mirror. So we trace it back, and then they appear to meet behind the mirror. That is case number 6 for concave mirror. Here also, this is the actual reflected ray. So what we do is we trace it back, and then they appear to meet at focus. So this is virtual image, okay, formed behind the mirror. All right. If it is a real image, it will be forming in front of the mirror on the same side as the object is kept. Understood? So it will be virtual plus erect. Okay, virtual and erect. So it will be virtual and erect. Let me just write here. All right. So case 1 done. Now we have only one more case. Okay, there are only 2 cases, so only one case is left. Let's do case 2. Case 2. So object position. Let's write here. Object position. Then image position. Image position. Then size and nature. Size and nature. So let's draw the ray diagram for case number 2. Okay, so let us draw the convex mirror here. So the mirror will be drawn like this. Let me draw a bigger one. Then mark the back side of the mirror. Mark the pole here, and then draw the principal axis. And then now, in case 2, the object will be brought in front of the mirror. But we are not going to mention, okay, where the object is kept. No need to mention that the object is kept at F or C. No, we are not going to do that. So I will not draw anything here. Okay, let it be anywhere here. So how are we going to write the how are we going to write it then? How will we write the object position? We will just simply write in front of the mirror. So the mirror is here and the object is here. So what do we write? We just write in front of the mirror. All right. So just bring the object here. Just let the object stand here above the principal axis and then right in front of the mirror. So in front of the mirror, it will be in front of the mirror. INFRONT, in front of the mirror. In front of the mirror. That's it. Then image position, we will have to draw the ray diagram, then we will know. So we will be drawing 2 rays. Remember, rays, we will be drawing the rays. The rays should emerge from here, okay, from the top. This is called the head, this is called the foot. Rays will never come out from the foot, okay, rays comes out from the head. All right, so draw 2 rays. First one, we will use rule number 1, where the incident ray travels parallel to the principal axis. So incident ray travels parallel to the principal axis. So this is the point of incidence. What will happen here? Reflection will take place. So this is a convex mirror, so divergent, it will diverge. So let us diverge it. Let me just find my focus. Let me keep it focused. Let me find my focus somewhere here. Let me mark my focus here. So if I do like this, then I should draw the ray like this. Okay. So if I trace it back, then it'll go here, 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 somewhere here. This is my focus. This is following rule number 1, which says that if the incident ray travels parallel to the principal axis, after reflection, it will pass through focus. Yes or no? That is rule number 1, is it not? Yes. Now we will use rule number, let's use rule number 3. Rule number 3, which will aim the center of curvature. So, little far now. I hope it's visible in the screen. So let me just put C here, and then now it will aim for C. Okay, so it'll aim for C. It'll aim for C. But is it visible or not? Let me just check. Okay, let me just check whether it's visible or not. So it is visible. Yes, it is visible. So this is visible. I have to check because I'm not okay. Whenever I adjust, I try to make sure that the edges of the whiteboard are not visible. So I have to see. So since it's visible, I can proceed. So now we will follow rule number 3, which will, okay, in rule number 3, the incident ray, okay, will pass through the center of curvature. So we have to aim this, we'll have to aim this. So the ray will start here, and make sure that you aim for C, okay? So aim for C. So make sure that you aim for C. I hope this is all right. Okay, I think we can get it from here. Let's do it. Okay, so this is the point of incidence, and we know that in this case number 3, where the incident ray aims for C, it exits, it reflects back through C. So this is the incident ray, it has touched the mirror here, and then it will reflect back from here. Okay, now we have to trace it back. We have to trace it back, so let's trace it back like this. So we have traced it back. Then we see that the 2 reflected rays, okay, on tracing back, they appear to meet here. So here will be our image. Here is our image. All right. So the object is here and the image is from here. So image is formed between P and F. Yes or no? P and F. Is it? Yes, P and F. So image position between P and F. That's it. P and F. Size. Object is this much, image is this much. What do we write? Enlarge? No. Diminish? Yes, we write diminish. Okay. So diminished. And then nature, it will be the same as this one because this is convex mirror. Okay. So nature will be virtual, and erect. So this is it, my dear students. This is it. these are the two cases of convex mirror. And how was it? Difficult? No, it's very easy once you know the rules. Okay, so make sure that you know the rules. So now let me erase this one and we will study the uses of mirrors. So this video is going to be a short video. After this we will study after this, so the next video will be about sign Cartesian, okay, sign convention. We will study about sign convention. In today's video, I'll just wrap up with the uses of mirror, and then we will continue with the next topic. I'm using cloth to wipe this whiteboard because my dusters are all like they have all accumulated this dirt, so I'm using this cloth. Actually, cloth is better. Now the next topic is uses, okay, uses of mirrors. So let's talk about mirrors. So uses of mirrors. So concave and convex, let's highlight here. And first we'll write for concave. And this side, let's write for convex. So concave mirror and convex mirror. Now let's discuss their uses. Uses number one for concave mirror. Concave mirror are used as dentist mirror. Dentist. Then number two, they are used in torches. And number three, they are used in car headlights. Car headlights. So these are the three uses of concave mirror. In exam, they will ask you maybe two, maximum two. So make sure that you remember at least two. Number one is dentist mirror. Have you ever been to a dentist? Yes, a dentist is a doctor who specializes in teeth. Okay, so if you have not gone to a doctor, if you have not gone to a dentist, means you have a good set of teeth. So good, very good, keep it up. And we have to take care of our teeth, okay, because if our teeth if our teeth is infected with cavities and all, we have to go to the doctor, and it's not cheap, it's expensive. Okay, dentist fee is expensive, especially if you're going to a private. So whenever you go to a dentist, the dentist will tell you to open your mouth, and then the dentist will examine your teeth, and with a special tool which has got a mirror attached to it. The mirror attached to it is a concave mirror. Okay, so concave mirror the doctor uses a concave mirror because a concave mirror produces a magnified image. So your teeth is very small, so in order to examine your teeth, the concave uses the special tool which has a mirror attached to it, and then with the right angle, the doctor will be able to examine what problem you have with your teeth. Understood? Next, torches. Okay, in torches, we use a mirror that is concave mirror. Okay, then in car headlights, so vehicular headlights, they have concave mirror attached to it. So these are the three uses of concave mirror. Then let's learn the uses of convex mirror. Now, uses of convex mirror, number one, they are used as rear view mirror. Then they are used as side view mirror. Then they are also used as rod reflectors. Rod reflectors. So these are the three uses of convex mirror. Number one, rear view mirror. This is found in vehicles. Okay, rear view mirror. So imagine I am the driver of a car. So this is the steering wheel. I'm holding the steering. Then right above my steering, this is the roof, isn't it? The roof of the car, there's a mirror. Okay, it's called a rear view mirror. So I can see, okay, I can see the passengers behind, right? And I can also use this to see the traffic behind. So this mirror is a convex mirror. So the next time you enter into a car, check out the mirror which is there, okay, above the head of the driver, which is a rear view mirror. It is used by the driver to see the rear. Rear means behind. Okay, front means in front, age. Rear means piche, which means backside. Okay, next one is side view mirror. So I am still the same driver. Then there's a door here, and immediately, okay, here near the dashboard, here on the outside there will be a mirror, which is called a side view mirror. Similarly, on the passenger side, because I'm the driver here, this side there is another seat for the passengers, you know. So there also attached to the door there will be a mirror. So there will be two mirrors, one on the right side, the one on the left side, which is used by the driver to navigate. Okay, he uses these mirrors to see the traffic behind, and at the same time he uses this mirror to see the spacing. Okay, the if it is a narrow road, these mirrors will help him know like where to how to pass through. So these are very helpful mirrors which are used by drivers, and these are attached in the cars. Okay, now why convex? Why convex? Convex mirrors are used because they provide a larger field view. Okay, they provide a larger field view. If I look at myself in a plane mirror, okay, my face will appear as it is. All right, so my face will appear as it is. But then if I look at myself with a convex mirror, the image of my face will be smaller. Okay, so I can see my entire face. I can even see what is behind my face. Okay, so this is possible with convex mirrors because they provide a bigger field view, which is really helpful for the drivers, because that will help them see, okay, like what's behind the car coming behind him. All right, so that is important for this is so important. That is why they are using vehicles. Then road reflectors, these are used in those junctions where we have 3-4 roads. Okay, mostly a junction will have many roads now, so 3-4 roads. So these reflectors are very important because it helps the driver to know whether a car is coming from the left or right. All right, so suppose a car, I am driving towards the direction, and we have a road coming from this side, and from that side also. So there should be a road reflector here, and if there's a road reflector here, I can see, okay, whether a car is coming from this side. I can see whether a car is coming from this side. Okay, front door I can see, is no, I can see. So no need for me. My worry is from the left and from the right. So if there is a road reflector here, I can easily look at the reflectors, and I can know whether a car is coming or not. So it helps me in my driving. It helps me prevent accident, and so these are very important. Okay, road reflectors are very important. They should be kept in every junctions and road dividers. Okay, so that accidents are prevented. So this is a life-saving device. Okay, which should be used in roads. Okay, so this is the topic today, a very short one. All right, but very important. So like, thank you all for tuning in. Now in the next video we will be talking about sign Cartesian. Okay, sign Cartesian, which is very important for numericals. So I'll see you in the next video, and God bless you all.